Hello and welcome to today's webinar with Styrenics Circular Solutions. I'm Victoria Hattersley, Senior Writer at Packaging Europe, which is Europe's leading intelligence resource for European packaging professionals. So for those who need an introduction to SCS, they are a value chain initiative dedicated to increasing the circularity of styrenic polymers. The title of our presentation today is Move to Zero, Zero Waste, Zero CO2. And your host for today is Chrissi Schönfelder, who is Chair of Advocacy and Communications at SCS. So without further ado, I will hand straight over to her. Welcome, Chrissi, and I look forward to hearing the speakers today.
Thank you, Vicky, for the kind introduction, and to Packaging Europe for co-hosting the event with us. A lovely good morning and a warm welcome to our online event. I'm Chrissi Schönfelder from Styrenics Circular Solutions, and I'm happy to be your moderator today. We are delighted that so many of you have joined us this morning. We had close to 1,000 registrations, so very glad to see the huge interest in circular styrenics. We titled this event Move to Zero, Zero Waste, Zero CO2, powered by Styrenics. And when we say zero, we mean actually the journey to the two aspects that we would like to discuss with you today, both the reduction of waste, how to turn the unique circularity capacity of Styrenics into reality, starting with polystyrene, and the favorable carbon footprint that it entails. You will be the first to know our brand new LCA results. For that, we are pleased to be joined by a wonderful and diverse set of speakers, Jens Kathmann, Herman von Roost, Norbert Niesmer, all representing SCS, Solenne Brouard Gaillot of Polystyvert, Dr. Chris Faulkner of Agilyx, Dr. Thomas Neumeier from Neue Materialien Bayreuth, Matthew Robin from Group Elsa Froma, and Tobias Strassner of Greiner Packaging. And furthermore, we also have one special guest, Werner Bossmanns, Team Leader Plastics at DG Environment of the European Commission. Before we get started, a couple of housekeeping remarks. We will hear from each of the speakers in turn, and later on we will have a joint Q&A session. We have already received some advanced questions from our audience, but it is not too late. Please do send in your questions throughout the event. If you look to the right-hand side of your screen, you will see a panel where you can type in your question. And we will do obviously the best that we can to cover as many as possible. As I say, it's a full agenda. Let's get started. And first, I would like to turn to Jens Kathmann, Secretary General of SCS. Good morning, Jens.
Good morning, Chrissi, and good morning, everyone. Thanks a lot, Chrissi, and also from my side, on behalf of SCS and the organizing team, a very warm welcome to everyone to our today's SCS LCA event. And to move on right into the event and the unique circularity potential of polystyrene, as we will explain again also later, let me shortly explain on the solid ground and demonstrate why polystyrene is designed by nature for full circularity. So how do we from Styrenics industry together with our value chain access the potential to close the loop? And first, and to start and end with the PS second life and the over and over again recycling loops we are targeting and we are demonstrating already today. More than 800,000 kilotons of PS packaging go each year into the European market, which is overwhelmingly food contact packaging, as you can see. You will learn later in more detail, but the sortability of PS, looking at this feedstock, at this tremendous feedstock we are holding, is really outstanding and is technically proven larger scale, and Herman van Roost will also explain on that. Secondly, and on the crucial technology link towards closing the loop, we have established 3 plastic-to-plastic recycling technologies on the way to the multiple recycling loops. First, the high purity mechanical recycling readily available in the market, almost a drop-in solid pellets. EFSA is well underway. Then secondly, dissolution, again, highly purified. We stay also as for mechanical on the physical, on the pellet solid level of polystyrene. And last but by far not least, depolymerization. our answer to chemical recycling. High temperature cracking of PS into its original building blocks. First and foremost, styrene monomer, going back to styrene monomer with all the process and purity advantages alike, the virgin monomer. So on the next slide, of course, it's shown, and it's, I have to say, amongst the many slides we have developed over the years together here with Chrissi and the team, it's really one of my favorites. Simply because it perfectly describes the multiple PS life cycle over our value chain, including the start of the second life or the end of life, but second life and the end user. Yeah. So if you look at the right of this slide, and let us stay there, following the route to our plastic to plastic recycling. We have the collection and the household waste, mixed plastics waste, for instance, yellow bin, separately collected and sorted from mixed plastics waste. This is highly important, separate collection and sorting, but we have it. From there, and easily on 99% of sorted PS fraction and food contact material sorted out, it's mainly high impact polystyrene we are talking here. You find in the center of the slide our three technologies I just described already, and the potential future chemical recycling route on the left side, which still is the option, but the good news is we don't need it today. So looking at the technology readiness level today, Styrenics are ready to start. We are there today, including chemical recycling, which is depolymerization. And to conclude why this slide is so perfectly describing the picture, and we always pitch at the end the LCA and the carbon footprint ambition we are holding. This all is now coming to reality. It's proven that PS is exactly on way to really closing the loop on excellent sustainability and the lowest carbon footprint. And surely everyone since is waiting for that now to somewhat disclose the LCA. Coming already to my last slide, and I make it now really short. It's really the uniqueness of polystyrene, of full circularity. We now have it all. I trust I have explained, and it will also be topic later. Feedstock, we can tick in the box. Looking at technology, closed loop, food contact material, we are done positively. We have accomplished our mission. And the output for food contact closed loop, including EFSA application started and well underway, more to come. This is all now completed, and recycling routes we have been focusing on all come to a significantly reduced carbon footprint, adding to the sorting and processes uniqueness I just described. So we are ready. We will scale up. We are starting. We are going in line with the European plastic strategy, as also later explained by Werner Bosmans, DG Environment, European Commission. But this, in order to keep it short, and over to you and back to you, Chrissi, from my part, and again, a warm welcome to everyone.
Excellent. Thank you so much, Jens. And without any further ado, let me already bring in our next speakers to lay the foundation of the later LCA results. We are going to look at the different feedstock preparation needs for each of the recycling technologies that Jens had just laid out, always with food contact in mind. And our LCA results are actually based on the Polystyvert dissolution technology, on Agilyx depolymerization technology, and on SCS high purity mechanical recycling processes. And with that, let me please introduce you Solenne Gaillot, CEO and founder of Polystyvert, Dr. Chris Faulkner, Chief Technology Officer of Agilyx, and Herman van Roost, General Manager, Feedstock, Mechanical Recycling at SCS. Each of them will give you their perspective. Thank you for joining, and over to you, Herman, first for the feedstock preparation needs and high purity mechanical recycling. Take it away.
Thank you very much, Chrissi. Indeed, let me explain you what we did in SCS and how we included the results in the LCA study. First of all, the feedstock. We chose the same feedstock for the three processes. And since we are going back into food contact, the logic is to start from food contact packaging waste. And obviously, it is in the households. So the process to get it from the households into a sorted fraction is perfectly included in the LCA study, of course. And doing so, we use conservative data. Basically, we consider the packaging, the PS content in the packaging to be 75%, which is often higher. But in yogurt pots, you can have indeed, let's say, if there is half a spoon yogurt staying there, then immediately you have a lot of residue compared to the polymer content. Throughout this process, of course, you have the separate collection. In Europe, there is 4% of the plastic packaging is PS. So we allocate for this whole process 4% of the footprint to the PS. We consider 200 kilometers transport. That allows then it's certainly conservative. It allows to have some intermediate storage. And finally, we consider here the sorting of the PS bales. And in the PS bales, we have a standard quality of 95% of object quality. So overall, that includes 700 kilo PS polymer content that we want to transform into food contact PS. Thank you. For the next slide, let's see how we do that. So actually, these bales are immediately available for feedstock for the high purity mechanical recycling and also for the dissolution. For the depolymerization, we want to increase further the polymer content. Yeah, and what we do actually is a standard basic mechanical recycling that you can find in the market. And typically at the end of that, you have washed flakes with 90% PS polymer content. Yeah. So let's go to the next slide then. And then here we are in the high purity mechanical recycling for food contact indeed. So the steps that you will find here are very similar to what happens in a PET bottle recycling process, but it is an enhanced process. It was adapted to the specifics of the PS packaging. So basically it starts with a very deep near sorting, and that allows already, while the packaging is overwhelmingly food contact already, that allows to increase further that food contact aspect to 99%. And on top, you can here sort on color if you want, etc., etc. So then we go to a hot washing, extremely important. And after the hot washing, there is already 95% PS polymer. So the residue is removed, the aluminium is removed, paper is away, etc. There's only other polymers there, and then these are removed in the flake sorting. At the end of the flake sorting, we have 99.9 PS polymer. Yeah, and that's so the basic the purity is already there, but in order to make it completely food contact, we pass through a super cleaning where substances. Potential substances are removed actually, and obviously to use it back into a nice white yogurt cup, we pass also to a very fine melt filtration. And so at the end of that process, the bales with 95 with 700 kilo per ton PS have become food contact pellets, and the amount is 650. So that's a very high yield actually. It's typically for mechanical recycling. The yield is the polymer yield is very high, and it is the intention of this process to remove everything which is not a polymer. So that's a high success here. Thank you for going to the next slide, where in the next slide we have to summarize what is the basis of this success. First of all, the high sortability of Styrenics. It's something that we had to learn through this phase, but we can really distinguish not only the different types of polymer, but also the different forms of it. The foamed versus not foamed, the XPS versus EPS. So that was a very interesting phenomenon. It allows not only to make real food, to produce a real food contact feedstock, but also to have very precise properties. Then something that was a great help is the low diffusion property of PS. Just like PT, the matrix is very closed, and during the use and waste phase, it does not absorb impurities. So, and to the extent that something would be in, it does not give it off into the food. So it's an essential characteristic for that polymer that it shares with PT. And then we let's say we had several successful challenge tests with existing technology. Nothing to invent. It's there. It's in use also for PET, but it's one of them. The noise is also in use in Japan already on PS. And based on these, we introduced this year, as most of you know, an EFSA application for food contact in all the typical PS packaging applications. So far, the high purity mechanical recycling. Back to you, Chrissi.
Yeah, thank you so much, Herman, for introducing us or updating us on the unique suitability for mechanical recycling for food contact for polystyrene. And with that, I would like to lead over directly to Solenne.
Yes, indeed. Thank you very much, Chrissi, and thank you, Herman, for this introduction concerning the feedstock preparation. At Polystyvert, we have developed a new technology to recycle the polystyrene in a circular economy, as mentioned. And please, next slide. Yeah, thank you. And one very interesting thing is that we do not need any kind of feedstock preparation for the GPPS. So the waste of polystyrene can be processed directly, just as it is. And the very first step is the dissolution. So we put the polystyrene in contact with an essential oil. So this solvent is a very, very natural product. And the polystyrene just dissolves very quickly, like sugar in coffee. And the beauty of this thing is that this solvent is selective of polystyrene. So the other plastic will not dissolve, what makes it very easy for us to filter them out. So we can easily remove the other plastics, but also cardboard, paper, metal, and so on. Then we apply a purification process. That's very, very important in order to get a very high quality end product. And this purification process basically allows us to remove any kind of impurity in suspension or in solution. So we are able, for example, to remove the pigment. A lot of yogurt cups, for example, are paint. So we can remove this painting. We can also remove fillers like the lime or the odor, any kind of additive in the polystyrene. And eventually the polystyrene is put solid again. So our end products are pellets of recycled polystyrene. And all what I told you is done at low temperature. So the mechanical properties of the recycled polystyrene are the exact same than the virgin polystyrene. That's the reason why the recycled PS can be reused for the exact same application than the original one. So that's a real circular economy. I mean that with waste of fish boxes, you can redo fish boxes. Or with waste of yogurt cup, you can redo yogurt cups. So that's a real circular economy. And another one very interesting thing is that the recycled polystyrene can also be sent in a reactor in order to do repolymerization if required. Indeed, the purity is high enough to allow a repolymerization process if you want it. So that's definitively very interesting. Moreover, the yield of this technology is very high. We claim a yield as high as 95 to 98%. And this seems very chemical, but actually it's not. I mean that there is no chemical reaction in our process, so there is no surprise byproduct. And since we are low temperature, we get an excellent carbon footprint. And eventually, since the polystyrene can be reused directly for extrusion, for example, we are the shortest loop, just like mechanical recycling. So that's very energy efficient. the fact of being energy efficient also allows to keep the capital expenditure very low. And also the cost of operation remains very, very affordable. So this technology allows a quick return on investment. Currently, we work on polystyrene, and we are adapting the technology with ABS. Next slide, please. Thank you. So on this video, you can see the dissolution process. So as I told you, we put the polystyrene in contact with an essential oil, and it dissolves very quickly. This video is real time, it's not accelerated, so you can see how quick it is. Wonderful. Next slide. Excellent. So here you can see a few pictures to illustrate my wording. So the kind of waste we can take for the GPPS, you can see that this directly comes from a sorting center, so that's pretty dirty. The polystyrene can be baled or not, and it can be processed directly as is. And the end product for GPPS is very crystal clear. So that's the proof of the quality of the end product. The sealant line is HIPs, so the waste of HIPs, as you can see, are very colored. And indeed, we are able to remove a discoloration just like any kind of other impurities. And the picture in the middle is our plant in Montreal. It is up and running since June 2018. And I'm very happy to announce that we just closed a funding round in order to facilitate the development of a full-scale plant in Montreal. So this full-scale plant will be up and running early 2023, and we are very, very happy with that. So the next slide. Thank you. So let's speak about food contact now. As I mentioned, our process has an in-depth purification technology. So this has the ability to treat waste with very high impurities. So that's something very, very important because obviously in the recycling world, the waste are very, very dirty. And our technology can handle any kind of waste, even if they're very, very dirty. Moreover, we did successfully pass the challenge test and the migration test. That are the tests that are required in order to meet the food agency expectation. And we did all these trials with Intertek, who is a very great and independent laboratory. That's a global company, so they work both in North America and in Europe. And for the FDA, Intertek provided us with a certification letter for food contact suitability. So that's something very important. And this work on both post-consumer and post-industrial products. So that's very, very positive. Now concerning the EFSA, we also work with Intertek, and they've confirmed the suitability of our technology for food contact product for post-industrial waste. So that's also very, very positive. And we did a couple of extrusion trials with some processor, so it works very, very well. The recycled PS can be extruded very easily. Next slide. Wonderful. So that's it for dissolution technology, and thank you to everyone.
Thank you, Solenne, so much. And with that, we jump right into the presentation of Chris. Chris, over to you.
Thank you, Chrissi, and thank you, SCS and Food Packaging, for the opportunity to discuss chemical recycling. It's very exciting to see my colleagues in the mechanical recycling demonstrate the work and the efficacy of the circularity of polystyrene in their fields. Agilyx has been in the chemical recycling space for 17 years, and polystyrene chemical recycling for the past 6. And we are a global organization deploying our teams predominantly in the US, in Oregon, where our facility has been running for the past couple of years. I'll get to that in a few minutes. And then we also have some offices based in Switzerland and Norway. Next slide, please. As we've been discussing the suitability for polystyrene to go back to food contact grade products, chemical recycling is somewhat different from the mechanical recycling process in that what we are interested in is the actual chemistry of the feedstock. So we depolymerize the polystyrene back to its monomer. And so since we are breaking down the polymer chain all the way back to its monomer, the polystyrene form does not matter. It can be rigid foam, film, it can be colored, it can be mixed polystyrene or Styrenics polymers, all into one feedstock suitable for chemical recycling. The important point is how much styrene is in that feedstock, because that is what we're aiming to recover. And polystyrene in particular, it lends itself to the unzipping of the chain to actually produce styrene monomer in high efficiency and high yields. And this is due to the polymerization mechanisms, as well as the actual geometry of the molecules itself. It lends to unzipping into the styrene monomer. There's a few examples of some of the polystyrene. You've seen those from Herman and Solenne in their presentations. Styrene, post-consumer, post-industrial, post-commercial, it doesn't matter. It's all great feedstock as long as the polystyrene is present. And in chemical recycling, we utilize pyrolysis. There's a schematic of our process on the right side of the screen. It's a pretty robust. It allows impurities in the feedstock and the non-polystyrene to be there, and we're able to still extract the styrene monomer in due process. It's much like any other chemical process. We have some feedstock handling in the beginning. The reactor is the heart of the system. That's where we recover and generate the styrene from the polystyrene feedstock. And then we separate the styrene from some of the other components. But predominantly, what we see and have been observing for the past few years is the unzipping of the polystyrene chain to that styrene monomer in quite a robust process. I did want to highlight our joint venture partnership with America's Styrenics, as we've been depolymerizing polystyrene under the joint venture since 2019 and using this facility for the production of styrene since 2018. And it's pretty straightforward. It's simple. You have your polystyrene feedstocks. We depolymerize it at the facility you see there in the image. And American Styrenics then makes polystyrene from our product, and then provides the styrene to our polystyrene to converters to produce any product. So it doesn't matter where the feedstock came from. It could be from the agriculture industry. It could be from post-consumer, your yogurt pots. It can come from even the life sciences and the vaccine development and all the work that goes on in the lab. All of those materials then are generated to the exact same molecule, the styrene molecule, that are suitable for food contact grade applications or any others. In this particular case and instance, the styrene monomer coming from this facility is branded under the name polyusable. So it's quite exciting. I'm excited to describe this process to you very briefly as we look toward the coming content of how efficient this process is, as well as the mechanical processes that you heard earlier, and the LCA impact. So thank you, and looking forward to the rest of the talk.
Thank you so much, Chris. And I would like to ask Solenne and Herman also to pop on your cameras, please, and would like to pass on to you a couple of questions that we have received here from our audience. The first one is, are your systems available only for recycling rigid polystyrene or also foamed? If you could give a very quick answer to this one. Herman first, then Solenne, then Chris, please.
We tested it first on rigid, and after the success, we tested it on foam, expecting to have big problems, and we didn't. There are no problems. It can be used perfectly on foam. The whole process until EFSA is, for the moment, limited to rigid, but we will not wait long for foam up as well.
Solenne?
Thank you. Yes, yes, indeed, our technology works on any kind of polystyrene, expanded or rigid PS, GPPS or HIPS. It perfectly works on any kind of polystyrene, and we are in the process of adapting the technology for ABS.
Yeah, fantastic. It's very great to see the expansion of mechanical recycling into all aspects of polystyrene. As mentioned just a few moments ago, chemical recycling is interested in the styrene content, so the source doesn't matter, the type of polystyrene doesn't matter. We can commingle the feeds or keep them separate. All of it is good, great feedstock.
Excellent. And there's another question that came in, and it was, what surprised you most when you were developing your technology? Again, first Herman, Solenne, and if Chris could comment on your technologies.
Well, Chrissi, the biggest surprise was that none of the tests that we did failed. It's like this product has been waiting for circular processes. We've completely underestimated it in the past, and so when we tried the sortability, we were surprised because nobody had demonstrated that before. The use of washing process, etc. All these tests worked very fine from the first moment. That's a big surprise.
I think that one thing that surprised me are, excuse me, but some comment concerning banning the polystyrene. I saw some discussion around this topic, and I find it very surprising because polystyrene is a very sustainable product. First of all, it has some characteristic that meet the requirements. So from a technical point of view, it works very well. That's an efficient material. It is very lightweight. It has great insulation properties. It is easy to break compared to other polymers like PP or PET. So in my mind, that would not be a great idea to ban polystyrene because this would just replace one issue by another issue. And instead of that, I think that recycling could allow this product to show the sustainability potential of it, because that's one of the most easy polymer to recycle. As you can see, there are different technologies that already exist and that already deliver. So I think that recycling the polystyrene would allow to create growth and to keep a great product on the market.
Thank you. And Chris, and depolymerization, you.
Yeah, it's such a fun question. You know, Agilyx actually didn't start with depolymerizing styrene in mind. We started with mixed plastics at large, and one of the surprising aspects is when we were differentiating our product platform and looking at our data was how easy polystyrene stood out to producing its monomer, and it turns out to be quite the elegant solution, and that's been fun from a technology point of view to see an elegant solution that works so simply that you can just it's easy to deploy and build and put on the market.
Thank you for that. And can you give us the couple of points? Why is it so easy? Why did it work so easily for you?
It's fantastic. So as briefly described a few moments ago, the structure of the polystyrene lends itself to unzipping to the styrene monomer. So instead of having an amalgam of chemistry to have to purify and refine and whatnot, as you see with other chemistries and other polymers, you get a high yield of styrene monomer and are able to put that back into the supply chain relatively quickly.
Excellent. Thank you. Thanks to the three of you. And with that, I would like to really dig into these LCA results for food contact, mechanical recycling, dissolution, and depolymerization. And for that, I would like to ask Thomas Neumeier, head of division polymers, Neue Materialien Bayreuth, and then later on he will hand over to Dr. Norbert Niesner, chair technologies at SCS. Over to you, Thomas.
Yeah, thank you very much, Chrissi, for the kind introduction, and thank you for giving me the chance to introduce really the latest results we gained on the life cycle assessment for polystyrene for food contact, mechanical recycling, dissolution, and depolymerization. Before I directly go into the results, I want to introduce the framework we have set for the whole LCA and to leave a few words on the tool of life cycle assessment, which I think is quite familiar for a lot of people listening to the webinar, but I think there are also some guests that might not have been in contact so far with the tool of life cycle assessment. So the LCA allows us to quantitatively do an in-depth analysis of a product, materials, environmental impact. And if we talk about a comprehensive LCA, we do not only talk about the so-called carbon footprint, or what we call the global warming potential. We also talk about other impact categories. We talk about freshwater consumption, fossil depletion, and so on, what we also considered within our life cycle assessment that we carried out here. But today, during my presentation, I will mainly focus on the CO2 footprint, so to say, the global warming potential. In the later on report that will be published, we will also have the other indicators. With our LCA, we can in principle look at the whole life cycle that you see here on the right-hand side of the slide. With our goal and scope of the study, we mainly focus on the recycling and the replacement of virgin material, which I will introduce later on. On the next slide, you see again an overview of the goal and scope of the study that we have set. So it was our goal to do an assessment of the environmental impact of different recycling processes for polystyrene, and above all, to compare it to current end-of-life options, which is mainly the incineration. And by this, we also wanted to see the ecological benefits of the technologies that have already been introduced to you. And we were able to generate a comprehensive data set that can also be used for further investigations. So within our scope, we had the three different technologies that had been introduced: the high purity mechanical recycling, the depolymerization, the dissolution, and we compared to incineration. The whole LCA was carried out according to the ISO standards 14040 and 14044 mentioned there. And we are really lucky to have high quality data that were provided by representatives from industry that run these processes and that have really reliable data on the mentioned processes. The results that I show today are not yet peer reviewed, but that will be following this webinar. So afterwards, we will have a peer review by a panel of independent experts. On the next graphic, we will see now we have again a view on the life cycle. As I mentioned before, the LCA can cover the whole life cycle. In this study that I will introduce here today, we started, as mentioned by Herman von Roost already, with the collecting waste at the end consumer, and we focused on the three different waste treatment routes, which are also mentioned here: food contact, dissolution, and depolymerization. And from all these three routes, we gained HIPS granules that can be used in food contact applications again. So what we covered here is that was what is marked in green at that graph as part of the complete life cycle. On the next slide, we see the two perspectives we have evaluated. We included two different perspectives into our consideration. On the one hand side, we looked at the waste perspective. So we said, okay, what does it mean to treat these polystyrene bales that were introduced by Herman von Roost to you? What energy effort does it need to treat them in the three recycling technologies compared to conventional incineration? On the other hand, we took the perspective of a part producer and said, okay, what is the product perspective? What is the effort for producing 1 ton of HIPS pellets based on waste feedstock compared to conventional virgin production? On the next slide, you see an overview of the technologies we looked at. So we have the mechanical recycling, we have the dissolution, and we have the depolymerization. Comparing to the incineration, the three recycling technologies already mentioned before, so they at the end we have plastic material, polystyrene material that can substitute virgin material. We have data provided by Polystyvert for dissolution and by Agilyx for the depolymerization process. And for the depolymerization process, I also want to mention that we can gain some very valuable side products, which is also indicated by a small arrow here. we gain the side products that can be used in other chemical processes, and we also considered this within our LCA. And for the incineration, of course, we have the heat and the electricity that is generated, and we took this also, we took care of this in our calculations. Yeah, on the next slide, you'll find again a summary of the boundary conditions in a formal way. So as indicated by Herman van Roost, we started with the waste collection from household waste with mixed plastic waste. He also already mentioned, he introduced the sorting technologies, and he mentioned that we allocated the necessary energy efforts for the sorting processes by a mass allocation approach to the PS stream, and at the end we get out the baled PS objects that are the input stream for our recycling technologies. For all our recycling technologies, we considered the same input stream, which is baled PS objects with 70% of polymer PS content. As mentioned before, we considered also the energy recovered from incineration as energy substitutes. And I think what is very important to mention is the geographical reference we took. So for the energy mix that was calculated, especially with electricity consumption, we used in the so-called EU28 mixer and European average energy mix. Yeah, and with that overview of the let's say the formal framework of our LCA, I will now directly come to the results that are shown on the next slides, and I will start with the high purity mechanical recycling to keep the same order as it has been introduced before. Here again, we see a schematic flow diagram of the process that we had a look at. We started with the collection and sorting on the left-hand side, where we gained the baled PS objects, and within the mechanical recycling, as already introduced by Herman van Roost, we have also to treat some impurities that have to be sent to incineration, what you see on the top, on the bottom right-hand side, and on the top of the right-hand side, you see our major output stream, which is the food quality HIPS substitute. Now, coming at first on the next slide to the results referring to the waste perspective. So what does it mean to treat the polystyrene waste fraction in the high purity mechanical recycling compared to sending it to incineration? And we see here quite a very significant saving of CO2 equivalents of 60%, which is in total numbers of more than 1 ton per ton PS objects, and it really proves that mechanical recycling is a very ecologically viable option for end-of-life treatment. But not only for regarding the end-of-life treatment, also looking on the product perspective, which is shown on the next diagram. There we look from the other side and see what is the impact if we want to purchase 1 ton of food contact quality material that is now based on waste feedstock compared to material compared to virgin material. And also see here we see a reduction of CO2 emissions of approximately 60%. And I have to point out again that we could really here consider in our calculations a quality factor of 1, as pointed out by Herman van Roost. The recyclate that we gain from this high purity mechanical recycling process has already food product quality, and we do not need any virgin material to add to this material. And of course, if we want to step into circular economy, what is then on the next slide, we do not only have to consider the impact of the waste treatment, we also have a combined approach. If we use feedstock from polystyrene waste, we can also avoid the production of new material. Both is taken into account in this calculation. And if we take into account both, we see a saving of 80% of global warming potential compared to the at the moment established route versus incineration. So here we really see the big potential for circular economy. Yeah, following the mechanical recycling, we will go over to the dissolution process, where we see on the next slide quite similar the flow diagram to that what has been introduced by Solenne in her presentation. We also see that PS objects after the waste collection and sorting directly go into the dissolution process, where we also have to handle some impurities that go to incineration, and the most or the biggest flow is the HIPS substitutes. I have to add here that the data for these calculations have been provided or has been provided by Polystyvert, as mentioned before. And now coming also to the results, at first from the waste perspective. And here we also see on the next slide a clear benefit from the technology of dissolution compared to the at the moment established incineration. We see here also a 45% reduction in CO2 equivalents. In absolute values, it is 800 kilogram less CO2 per ton of PS objects that is emitted there. So also a very ecologically favorable option for end-of-life treatment. And also from the product perspective that is shown on the next slide, we see a clear benefit, and as already pointed out, also here we can reach food quality. We have also a quality factor of 1, and we also gained, compared to the production of virgin material here, a saving of 45% of CO2 emissions. And also for that route, on the next slide, we compared we calculated a scenario where we included the waste treatment as well as the avoidance of incineration. And here we see a tremendous benefit also for the route of dissolution, which is really capable of establishing a closed loop circle. So we have a CO2 saving of more than 70% of approximately 75%. Yeah, last but not least, regarding the 3 technologies, I will go over to the depolymerization technology. Here the flow diagram, which represents in a bit other way the diagram you already have seen in Chris's presentation. You see here, coming from the waste collection and sorting, the pre-treatment. You see that also the impurities from pre-treatment and depolymerization are treated in incineration. And what is on the top right side, what you can recognize there is this line that is marked with valuable byproducts. I indicated that before. So besides the HIPS granules from the depolymerization, we can also gain some other chemicals that can be used, especially if the plant is based or is integrated in a huge chemical plant that can directly be used for other processes. And also these valuable byproducts were considered in our calculations, for which I want to show the results now with the first diagram on the next slide. Also starting with the waste perspective, and also here it clearly shows that if we use depolymerization instead of incineration for waste treatment, we really gain a tremendous ecological benefit, reduction of more than 60% in carbon footprint. But if you look closely here to that diagram, you see on the top of the green column a small bar that is a bit more in detail explained on the next slide. For the depolymerization, we took into account different scenarios within our calculations. We accounted for different scenarios regarding energy supply. We we looked into different options for using these valuable byproducts. And also we considered possible scaling effects, which I think will be addressed later on more in detail in this webinar. And that's why we indicated a small range for the CO2 footprint for this technology, but in average, we really can say the 60% reduction for this technology. Now I want to introduce the product perspective. So what does it mean to really get, as Chris indicated, a again polymerized product based on weight feedstocks? So the chain has been cut down and now repolymerized again. So it's really virgin-like quality. And also with this, we can get a 35% reduction compared to producing virgin material based on fossil feedstock. Yeah, last but not least, also for the route of depolymerization, we calculated the scenario where we see, where we considered the waste treatment, and on the other hand, the avoidance of producing fossil materials. And here we can clearly see that per ton of PS objects, we can save more than 2 tons of CO2, which is a reduction of 75%, and gives us really the possibility for establishing a closed loop circular economy without downcycling the material. So coming to the end of the introduction on the LCA results, on the next slide I have summarized the points I tried to communicate within my short speech. I hope you got an insight in our comprehensive LCA based on the already mentioned standards. And I really want to point out once again that all shown technologies are ecologically favorable options for the treatment of plastic waste. As mentioned at the beginning, we looked here only into the CO2 footprint, into the global warming potential with respect to my presentation, but in the study we did also consider other impact categories that will be included in the report. And I can also say that also with respect to the other impact categories, the recycling processes are quite favorable options. The benefit is shown on the waste perspective as well on the product perspective. And these technologies really show an outstanding potential for circular economy, at least from my point of view, having a look at the calculations. And with this, I would like to hand over to Dr. Norbert Niesner, who will give a more insight on his view on the results from a more industrial standpoint of view.
Right. Great, Thomas. Thanks a lot. And let me pick up already one slide that you presented as my introduction slide, because I want to focus today on the depolymerization, because the depolymerization is really unique with polystyrene. As Chrissi said, we are blessed by nature. Actually, it was Herman Staudinger and Herman Mark in the 20s of the last century who created that molecule, but we are blessed by a certain combination of unique properties that makes polystyrene really unique. And the one thing that makes it unique for depolymerization is it has a benign decomposition temperature. So if you heat it up, let's say 200 centigrades above the typical processing temperature, that is safe enough for great processing, but it actually creates very selectively styrene as a monomer, which is unique. There is really no other polymer doing that, and except maybe PMMA. But it creates also a low amount of byproducts which we can valorize, and that all was taken into account into this calculation. So also the yield and so on, and therefore, due to this unique property of polystyrene, we end up in a great score with this unique recycling method, and saving us less than 2,000 kilograms of CO2 per ton, actually. And what I want to point out is that this advantage of more than 2,000 kilogram of CO2 adds again and again with each recycling loop. Sounds trivial, but is not, because we are not converting, let's say, yogurt beakers to, let's say, fibers and then incinerate or so. We turn from packaging material to packaging material, or we can create other high quality material without quality loss, and that's the unique thing. So there is no, let's say, slide trend towards downcycling. It's not. It's a closed loop recycling without any quality reduction. Yeah. So the next slide, please. We have, as Thomas mentioned, we have taken a few very, let's say, conservative, solid, and internally reviewed within the industry, participants reviewed assumptions. So I think this study is as solid as it can be. Nevertheless, we see further upside potentials, which we have not yet factored in. So we have included a slight, let's say, capacity increase from current early commercial stage. But if you compare that to a, let's say, 500,000 ton world scale plant for styrene, we are still below that, and therefore we are not comparing on par. So that needs to be factored in. Actually, we have not, yeah, just to stay conservative, but there is of course an upside potential. The bigger we get, the more we run through the experience curve, the more we have economies of scale, the better CO2 balance we will get. And as I'm in my function as representative or as responsible person for R&D at INEOS Dissolution, I can confirm that we are definitely not at the end of the process development. We will continue and we will further improve, and that is true for all participants. We with partners, we will improve the yield and the depolymerization. There is still a lot of potential there, which has not yet been leveraged and which will create further upside potential. We also have not included the point of using green electricity. We all know that this is up and coming, especially here in Europe, so a great story, but we have not yet included. And last but not least, not part of this LCA is of course the let's say the less energy demand in the use phase. So for polystyrene, you don't need pre-drying. It's amorphous material, so the energy to heat it up, to melt it is lower compared to partly crystalline materials and so on. And therefore the material is ceteris paribus, so under the same conditions, faster in processing speed. So as a summary, we can say further significant upside potential on once PS depolymerization emerges from its current early commercial stage into full industrial scale will be applied. The next slide, please. The fact similar to what Solenne mentioned, the fact one unique value proposition of polystyrene is its easy recyclability into truly circular food quality or virgin quality products, and that you can do also for other polymers, but with more processing steps. So we put here a few examples. I don't want to go into details. We can discuss that later, but my message is the easiness of depolymerization makes polystyrene fully circular with a minimum of steps. And that's my message. Thanks for listening, and eager to discuss with you later. Thank you.
Excellent. Thank you, Norbert. Please leave your camera on, and I would also like Thomas to turn on his camera for a couple of follow-up questions. First of all, to the audience, Thomas has already stated that this LCA will still be peer-reviewed, and we will certainly then also report back to you once we receive the peer reviews. Thomas, a question over to you. How does this LCA study and its results compare to other LCA studies? Can you give us some insights?
Yes, of course. That's a great question, Chrissi, because on the one hand side, our study is very unique. Yeah. As pointed out, we have really the same input conditions for all the three recycling scenarios. And what I also want to really emphasize once again is that we have very high quality data that we gained from the experts from industry that run these processes. But you also asked how we can compare with other studies, and what is really comparable to other studies that have been recently published is the clear benefits that all recycling technologies show compared to incineration, with also considering, even if we consider the energy recovery for the incineration. Yeah? And this is in line with other recent studies that have been published.
Excellent, thank you. And a question over to you, Norbert. You pointed out the increasing emissions savings with each further recycling of polystyrene. So the question is here, doesn't it go without saying, and isn't that true for all recycling of all plastic materials?
Yeah, Chrissi, you're right. I mean, in principle, this is true for all plastics, but we have the ambition to truly be circular, and I cannot emphasize this enough. Truly circular means not going from, let's say, beakers to fibers and then to waste, or to 2 or 3 stages and then not being able to use this plastics anymore. We want to go from, let's say, packaging to packaging to packaging to packaging, and so on and so forth. So truly circular. So basically, we are aiming, and we have reached the, allow me that word, the S class amongst recycling. We are truly circular, and these 3 presentations this morning showed you that we are not accepting any compromise in that. So therefore, we should emphasize that, yes, we will reach this benefit over and over again. Yeah.
Excellent. Thank you so much for that. And with this, I would like to come to our panel discussion, focusing on the synergies between the 3 recycling technologies and the implications that the LCA holds for the value chain. And therefore, please welcome back Solenne, Chris, Norbert, and Herman to this panel discussion. So, the Styrenics value chain, as we heard, is quite fortunate to have multiple recycling technologies at their fingertips, each of them able to produce food contact, one of the UVPs, as has been stated here. On top of these 3, PS can, as Jens had shown in his first initial slide, also go back into pyrolysis, all the way back to the steam cracker. So the question here is, why is the value chain not uniting behind just one technology? And why not make this one technology mechanical recycling only, which we've heard from Herman is also closed loop food contact recycling without degradation over and over again? Why not going the easiest way? Let us start here with that question. First over to Herman, and then I would like to ask also Solenne and Chris, and finally Norbert, to comment on this one. Over to you, Herman.
Thank you, Chrissi. First of all, our industry has a very high ambition. We want to mobilize all the competencies that are available in the value chain. And in some cases, what is easy for one industry, or what develops a lot of synergies for one industry, is not necessarily the same technology. So for a petrochemical industry, there are tremendous synergies to do the chemical recycling, the depolymerization. But let's say the typical advantage of the mechanical recycling is that it has a very low access by any industry. If you're a recycler, if you are a converter, even a brand owner, or a polymer producer, yes, indeed, there is nothing that stops you from doing that. Even if you're a PET recycler looking for diversification. So it is really low access, and so so has the broad range of technologies will help to accelerate the circularity of PS, because we are in a hurry. Yeah, we are very ambitious.
Now over to you, Solenne, for dissolution. Why would dissolution also be needed?
Thank you. Yes, indeed. I think the plastic waste issue is a very large problem. You know, that's a global problem. And I don't think that one magic and unique solution will fix all the problem. I think that we need different approach to collectively find a global solution. So each technology has some advantages and obviously disadvantages too. And I speak for my case, the dissolution technology is very strong in order to treat a contaminated feedstock. We are able to remove contaminants like painting, for example. So this really allows a circular economy for some specific product. We can treat any kind of feedstock thanks to this in-depth purification process. And I really would like to emphasize on the circularity, as already mentioned by other players. That's really important to have a high quality end product in order to set a real circular economy and to avoid any kind of downcycling, you know. For example, taking some waste of food product and giving a second life to use into tires, for example, is probably not something very circular.
Chris, what's your take?
Yeah, so I mean, there's 17 million plus tons of polystyrene that are produced and put onto the market in various styrenic polymers, and that's quite a lot. And we want to accelerate the capture of those and put them to their highest and best use. And I think you heard today that there's some nuanced difference between the feedstocks that each technology is suitable for and the addressable market that you can achieve those. So really, I think it's about promoting and lifting and really pursuing for recovering all the polystyrenic polymers and you know, getting them back into the circular economy, as Solenne mentioned. And there are a variety of ways to do that. And if you only rely on one, you're heavily tilting the supply chain to one area. Competition is good. It helps us all sharpen our technologies, be a little better, and continue to push forward. So it's very exciting to me to see you know, all these technologies come to fruition. We each have a place to play, and we're going to be accelerating and recovering more styrene and polystyrene to put back into the market.
Excellent. And Norbert, from an industry perspective, you can choose any of these technologies. What's your take?
Exactly, Chrissi, and you addressed in your question also the value chain. And I mean, you might know this year we celebrate the 90th birthday of polystyrene. So this product has the longest, let's say, experience in applications in the market, and that's where we benefit from. And I think we were all waiting for high-end concepts, still practical concepts, to fulfill recycling quota. And here they are. I mean, it took us some time, but we are very solid working, conservative people. And when we say something, that's true for all SCS members and all stakeholders in this value chain, in this industry, then it fits. And I think I can proudly say with this event today, we come with a very solid, doable proposal which makes polystyrene the material for packaging.
Excellent. So I hear you that you're saying, first of all, you all want to have your molecules back into recycling. And as Herman put it, it increases the available PS feedstock for our recycling technology and accelerates the competition aspect, accelerates our readiness to deliver recycled polystyrene on the market. All of them are complementary. Another question, if I am a brand owner and RPS from the different technologies is available, for which recyclate do I go to? What are the limitations per technology? Herman, this one over to you first.
But Chrissi, if you have 3 great products which are virtually equivalent, The best is to enjoy the diversity and let the market play. That would be my recommendation.
Solenne.
Yes, I think the brand owner would make a strategic choice depending on their own strategy in their own company. You know, I think that different technology are all able to meet their expectation, but maybe someone would focus on the capex, another one would focus on the opex, another one would have access to some specific feedstock or not. So as per me, it does not depend on the technology, but much more on the strategy on the brand owner, and as much as they want to have a real impact on the environment.
Yeah, that's right. To add to the discussion, so you know, from a chemical recycling perspective, we're producing a styrene monomer that can go into any of the polystyrene applications. So the brand owner is just going to be choosing styrene for its chemistry and polystyrene for its chemistry, just like they would with their typically fossil-based polystyrene. So they have, but they can have the comfort from these technologies that they are all LCAs, as reported by Thomas, are very favorable and moving in the right direction. And there's even more excitement to come in the future. So I think it's quite a decision to have in front of you, to have options and to suit your needs.
Excellent. Norbert, any further?
Right. I mean, as it was introduced by Jens in this nice first slide, we have this, let's say, simple yet genius advanced mechanical recycling method. We have a little bit more effort, but more reach with dissolution, and a little bit more effort and even maybe more reach with depolymerization. So these three technologies, they complement each other, and that would be my message today. They are not in competition, so the brand owner, the OEM, the OBM has to decide, but they are really complementing and have different reach. So it's like a cafeteria concept. So it's depending on the applications, really the OEMs can decide. One thing all have in common, and let me emphasize that again and again, it's fully circular.
Excellent. And from the perspective of, you have led here the working group at SCS who has done the LCA analysis, having seen the results and knowing that they are all favorable for each technology, what do you say are the key takeaways for the value chain? What should it mean for the downstream users? I think
it became clear today that we do good things to our Mother Earth when we recycle polystyrene, and I think that is a message that was missing for quite some time, we have to say. And it required some work, and we are now finished with it, and it clearly shows and even exceeds, I must say, expectations of most stakeholders how beneficial polystyrene scores in this field. And together again with this full circularity, I think that's a great message for downstream users, knowing they can rest assured that by choosing a packaging made of polystyrene, they do the right thing for the nature, and they are aiming for the title of our webinar, going the way towards zero CO2.
What I'm hearing is what we had already confirmed in the first webinar last year in November was that polystyrene has a lot of benefits in the use phase, which were excluded from the study, like the energy efficiency, the stability achieved with less material, for the packaging, the cost effectiveness that it includes, and processability, up to the famous snappability of the multi-pack yogurt cup. And now you have stressed that came with the additional benefit of a truly circular polystyrene, and now also with sustainable solutions, or the confirmation of sustainability for all the three technologies that we are working on. Excellent. Thank you with that. Thanks so much. for this thought-provoking discussion. And with this, I would like to move on to our next agenda item and actually move on to those that are at the front line of bringing the circular polystyrene packaging to the end consumer. And I would like to welcome here for that Matthew Robin, CEO Group ELSA Reformer, and Tobias Strasser from Gaillot Packaging.
Good morning, everyone.
Hello to everyone.
ELSA Reformer are part of Migros. Migros is the largest retailer in Switzerland and actually with a quite remarkable sustainability performance rating. And both ELSA Reformer or Migros and Gaillot Packaging have both been working together on a yogurt cup from mechanically recycled polystyrene for the Swiss market. Matthew and Thomas, before I ask you both what the LCA means for you, let me first quickly turn on to Tobias to understand the converter context. Tobias, you used the mechanically recycled polystyrene in your production facilities. Can you give us a quick update? How did recycled polystyrene perform in your plants in comparison to virgin polystyrene?
Yes, sure. As we heard about chemical recycled material, there is really no differences. So therefore, we're concentrating on the mechanical recycling materials, and we was testing it along our processes as from the converter perspective, like thermoforming and the extrusion process. And we can really confirm that we have no influence on every process. We can really handle it like it is with the virgin material. It's a truly drop-in solution, as we heard from the reference before, and we made great experience also with the mechanical properties and all the other needed properties for bringing it successfully to the market. And it's really great. Honestly speaking, we was also wondering how does it work, but from our perspective, it's just a drop-in solution.
So also positive surprises there. And in terms of the output, the quality, what have you seen there with the mechanically recycled polystyrene?
So from our perspective, with our processes, we have absolutely the same properties on the machineries, with the same output, with the same speed, with the same behavior in almost every topics. So when we do some top load tests and all what we need to ensure the quality at the end before we bring the product to the market, there is really no negative influence.
And I can confirm that we've run on our machines in our factories, also worked like virgin material. The one thing we see a difference in is a very slight difference in color. And I think I'd say that's the only discernible performance point where there is a difference to virgin material.
And I guess that is something that all recycled polymers do show. And maybe, Toby, you can comment on that. Is there anything that can be done, or how can color, the white color, be adjusted?
Yes, I mean, that's on all polymers. If you get post-consumer waste back from the consumers, there is some influence, and at the end, it's kind of the process of mechanical recycling, and therefore the question is how many money at the end you would invest, and how many losses you would have in this mechanical recycling processes. If you do more efforts, you get whiter and whiter material, but at the end, it should not be only ecological solution. We need also economical solution for the market. That's clear.
Yeah, and I think, I mean, Tobias and I, our companies discuss this, and at the end it's the consumer who's going to decide. But I think the consumer is used to recycled materials. I mean, if I think back as a consumer, recycled paper, the most ecological is also slightly grey. The grey color in, or the slightly off-white color in the recycled polystyrene, it affects very slightly the color of the yogurt as well. But consumers are used to slightly less colorful yogurts when they're organic. And so it is associated a slightly duller color with more ecology, certain elements of quality. So our initial tests are very encouraging, and we think we'll get good consumer acceptance. The proof of the pudding is always when you go to the market, and I think that's a process which we'll do together. And what I can say is that Migros is committed to recycling, to the circular economy, and so of course we'll be communicating as well as we can to explain to consumers what's happening, and to hopefully win them across to this advance in ecological production. And I'm convinced we'll have good results. And I think very encouraging is we have other industry manufacturers who are interested in joining us on this effort.
And you're doing that actually in a quite innovative way, the communication to your customers. You don't only involve them at the later stage, when you bring the yogurt cup into your shelves, but you live that recycling starts with collection. You've started your own collection of plastic packaging in Switzerland and have asked end consumers to return their household packaging to your retailer outlets. Can you talk a little bit more about that?
Yes, I mean, of course, recycling is great in theory, but if you don't get the plastic back into the recycle loop, you can't even start. So recycling in Switzerland is something that's well established, but mainly for PET and some other plastics, but actually not for polystyrene up to now. And to address this, Migros has introduced recycling bags of mixed plastic, where at the moment it's a test with 50 shops, but to be expanded, where consumers can bring back all their plastics to be recycled, and the separation takes place further down the process. And the objective of this is to make it as easy as possible for consumers. The easier we make it, the more material we'll get back, and the more successful we'll be in really getting to the critical amount of polystyrene to recycle.
I would really stress out this point with we have to get the plastic back from the consumers, and we are really thankful that we have this partnership with Migros Industry and Migros to do this, because we have a lot of brand owner and also wholesalers who are asking about recyclability, but we have to work together, and we have to build strong partnership to come to this point, because that's at the end of the question about the chicken and the egg, what is first. And so thanks to Migros that they are really do so much efforts into this topic.
Yeah, I mean, and why are we investing these efforts? Of course, it's philosophy, sustainability. Migros is here to make life better for Swiss consumers, and this is part of a better life, we feel, is a more ecological life. But one particular aspect with polystyrene is actually its functionality. And consumers in Switzerland, they buy yogurts in duo packs, so 2 yogurts at a time, and they can separate these in the shop and buy 1 yogurt, or they can buy 2. And of course they can separate at home, and this has great convenience for consumers. It's also great for the shops, because it's very good to get proper product facing on the shelves. So we love the properties of polystyrene and really want to keep polystyrene as a viable material for food packaging. And of course, how do we do it? we recycle it. Unfortunately, as we've heard from the previous speakers, it's very suitable to recycle.
Excellent. And what I'm also hearing is that you also are not alone here in terms of critical mass. I think what called packaging household waste in Switzerland, but you also have other retailers that join you in that.
Yes, I think we hope so. We try and cooperate, and the other retailers are also very much committed to a similar philosophy. I think Migros is pioneering in this area, also because of our food production plants, because of Elsa as one of the major yogurt producers. But fellow retailers in Switzerland, this is we all do together. I think we all want to put aside egoism and put aside trying to differentiate at the cost of the environment. So we certainly welcome all of our partners, all of our competitors as well into such recycling initiatives. That I think is very important to say, and I know our competitors, they behave in the same way. This is the only way we're going to succeed in the world today.
Excellent. And what I said previous to this call is you compete with your competitor with the yogurt itself, but in the packaging you are united.
Exactly. When it comes to packaging recycling, we're together. Otherwise, yeah, we do everything we can to gain market share.
Excellent. One last question to you. LCA was made for the closed loop recycled polystyrene intended for food contact. What significance do these results of the LCA have for you or for your customers?
Yeah, I think data is very important. So when we communicate with customers, we have to be careful how we communicate. We have to communicate very simply, because customers react emotionally and not really to science and to facts. But we only do things if we are convinced as a company, and we're convinced as Migros, that the facts stand behind what we're doing, i.e. that we're really doing something good for the environment. So the studies are very important for us, and it also enables us to communicate properly, because we do also communicate facts, of course, and we do have consumers who are very interested. We give them access to facts. So we have to find a balance, and we do this to find a balance between providing data, but also communicating in a simple, emotional way, so that our consumers will welcome change and not reject it.
Thank you. All right, super. Thank you so much. That was a very encouraging message from both our converter and retailer. Thank you, Tobias, and thank you, Matthew. And with that, it is now actually time to look at the bigger picture from realizing the circular economy for PS now over to plastics in the circular economy. And for that, I am very much delighted to have Werner Bosmans with us from the European Commission. He is the team leader plastics at the Directorate General Environment. Very good morning to you. Welcome, Werner, and I hand straight over to you.
Good morning, Chrissi, and good morning to all participants. I see this is an incredibly well-attended webinar, so I will do my best to give you an overview on plastic policies, the ones that we have and the ones that we are developing within the European Commission. Could we go to the presentation, please? Voila, it's about plastics in the circular economy. Obviously, I think that's already obvious for about most of you. Next slide. So what is the bigger framework? I like to take one step back for this. So first of all, we have the European Green Deal. When this new Commission entered in office with President von der Leyen, it came up with the European Green Deal, and which is still the main priority, so the policy that's heading all others. And this is about a climate neutral, resource sufficient, and competitive economy. It tries to find the right equilibrium between those objectives. One important there is obviously climate neutrality by 2050, but not only. A further step we could say down is the Circular Economy Action Plan, which a new action plan came out in a bit more than 1 year ago. And there the main objective is to have an economy where the value of products, materials, and resources is maintained in the economy for as long as possible, and the generation of waste is minimized. Now, within that Circular Economy Action Plan, we have a couple of headline policies. I would say the first one is the Sustainable Product Initiative, where we try to have sustainable products as a given on the market. It will build on the existing Eco-Design Directive. Think about the labels on your fridges and how that deals with energy efficiency, but this will go about virtually all products and virtually all impacts. Of course, some prioritization will be done. And the first prioritization is already that we're looking at key value chains. Plastics is one of these. And the next thing that is very important is that we want to see less waste, more value. So we want to see waste as a resource, ultimately to change the way Europe consumes and produces. Next one, please. So an important part on plastics is obviously the plastic strategy, which deals with the fact how we can make plastics and industry enter the circular economy. The first main objective there is to improve the economics and quality of plastics recycling. And then if you look at this, you really look at plastics as a material. There are products which are completely made from plastics. All our product policy still remains into place and remains valid, obviously. So durability of products, repair, remanufacturing, that all comes before recycling. But for plastics as a material, quality and the recycling, the volume of recycling are extremely important. We have obviously as well this very important objective to curb plastic waste and littering. You all have seen the images and you know that is very, very high on the political agenda, but as well on the public agenda. It's a real concern of citizens. We have two a bit more instrumental objectives in the plastic strategy. One is to drive investments and innovations towards circular solutions, and the other one is to work together with our global partners. Next one. Aside, we have our waste legislation into place. So we have our Waste Framework Directive as amended in 2018. So the same, a couple of months later as the plastic strategy. An important issue there is the updated calculation methods on recycling targets, because we had a multitude of methodologies. It will now be measured at the entry of the recycling plants. There are as well updated plastic packaging recycling targets in our related directive. This is the directive on packaging and packaging waste. So by 2025, we need to obtain 50% for the whole of the EU and 55% by 2030. And then we have this very emblematic file, the directive on single-use plastics, where it is the intention, first of all, to reduce marine litter, and where we're looking at 10 items that are contributing a lot to this marine litter. Next one, please. So let me now try to explain a bit what we're going to do the coming year, the coming years. what is written in this new Circular Economy Action Plan as new priorities. Next one. So as said already, in this new Circular Economy Action Plan, we're looking at key product value chains. Plastics is one of them. You see the other ones on the circle on your left. So we have cars, we have packaging. I'll say a couple of words on this later. So plastics, textiles, construction, food, and electronics. Now, the first thing that this new Circular Economy Action Plan says that it will continue the implementation of the EU strategy for plastics in a circular economy. So even if that plan comes from the previous Commission, this Commission stands 100% behind the plastic strategy. Obviously, like always, they put up a couple of own accents, but in fact, they just take the existing agenda one step further, which is logic after a while. So we are going to look at introducing mandatory requirements for recycled content and waste reduction measures. We're going to look to the presence of microplastics in the environment and as well on how to deal with bio-based and biodegradable plastics. This last point is a bit out of scope on this conference. I can just tell you there that under certain circumstances, bio-based plastics can obviously contribute to the circular economy. And bio-based, and you talk about the sourcing of the plastics. Biodegradable plastics, you talk about the end of life, and there it is the same. For certain applications, there are benefits for certain applications, not for all. Next slide. Let me go a little bit more in detail on recycled content. You know that, or many of you for sure know that in the plastic strategy, we have put up the aim to reach 10 million tons of recycled plastics in new products on the EU market by 2025. To achieve this aim, we have set up, together with all businesses and business associations, I think almost 300 members now have set up the Circular Plastic Alliance, and the members are really working very hard to put up the right conditions to achieve this target by 2025. It is a little bit too early to say if the target will be achieved, but at least industry is really doing its best to put up the right framework in place. Aside, the college, so the commissioners have asked us to work on mandatory requirements for key products such as packaging, construction materials, and vehicles. Here very much supported as well by member states and European parliaments. Next slide. Just a couple of works of microplastics. Microplastics, unfortunately, is part of the leakage of plastics, mostly. There are two main parts on microplastics, the one that you deliberately add to products, and then we're coming to cosmetics, detergents, and paints, mainly. There we are aiming towards a ban through a REACH restriction dossier, and most probably this will happen by 2022. The other main sources are tires, textiles, and pellets, which are rather through abrasion or the use of those textiles or the uncareful handling. For each of these, we are looking at more specific measures. And then more in generic, we're looking at microplastics in water, where we are looking both at the science as at legislation. Next one, please. The other key value chain that is important for your sector is packaging. And the main objective there, and it was already in the plastics strategy, is to make all packaging on the EU market to be reusable or recyclable by 2030. And I think you are aware of that. It's not just recyclable in lab condition, it should happen at scale, cost effectively, so really on the market. We want to reinforce the mandatory essential requirements for packaging there, looking at the design for use and recyclability, to look at how we can have a better separation of packaging waste, and something quite important, how we can enforce the rules for safe recycling into food contact materials or plastic materials beyond PETs. Colleagues are working very hard on that, and we hope to come up with further things on this in the coming months. Next one. Cross-cutting is more less waste, more value. As I said already, this is about preventing waste, but if it is created, it should be transformed into high quality resources. That we think goes together with a toxic-free environment and a good functioning EU market for secondary raw materials. Some instruments that we will use there, we will look at EPR schemes, how to improve that at the European level as well. We are busy reviewing the rules on waste shipment, mainly to facilitate recycling and reuse within the EU, so less out of the EU. And in the meanwhile, we have as well our chemicals strategy for sustainability that will help. Next one. We have 3 other cross-cutting issues as interest for your sector. One is getting the economics right. We have our new own resource for the EU budget, which is based on the amount of non-recycled plastic packaging waste. The implementation of this is the full responsibility of member states, and it's up to them how to decide how they will pay this contribution to the EU budget. We will continue to push for innovation. 2 important things there, the substitution and elimination of hazardous substances. It should be safe by design. And we will explore as well the potential of chemical recycling. I'll come back to that in 5 seconds. And we will continue to lead efforts at a global level to set up a global agreement on plastics. Next one. Chemical recycling, where do we see the role? Well, first of all, we will only consider it for waste targets if it produces plastics, substances, and not fuel. So we see it very much as complementary to mechanical recycling, so it should not replace mechanical recycling. In particular, where it can eliminate toxic elements and hard to recycle plastics. So life cycle analysis is needed to have a good view on the benefits and risks, including energy and climate impacts. And obviously, there's a lot of pilot projects already now, but we think that they should be expanded to have a representative picture of the potential. But we do see a clear potential here, and I do know that your sector is very hard working on all these elements. Next slides. So to conclude, what is the way forward? So for the circular economy, you know that it's keeping products, materials, and resources in the loop and their value for as long as possible. For plastics, it's about no littering, no leakage, and then recyclability, collection, recycling, and uptake of recycled content. For packaging, this is applying these principles and focus on prevention, design for reuse, and recyclability. And last slide, please, so that I can thank you for your attention. Up to you, please. Thanks.
Excellent. Thank you so much, Werner. We really appreciate your perspective and engagement here with the value chain in this joint mission to turn the circular economy into reality for plastics, for all plastics, and certainly for polystyrene. And with that, I would now like to turn over to our audience and to your questions. We have, in the meantime, received a flood of questions. So one of the questions that I see here a couple of times, how often can PS be recycled without degradation to be used as food contact material? And with that, if every one of you could, of our panelists, could switch on your cameras. And I think this is a question that very much goes to what Werner has presented. How long can the value of our polystyrene be retained in the process? So with that, I would like to put that question first over to, let's put it over to Herman first. how often can polystyrene be recycled via our high purity mechanical recycling?
Thank you, Chrissi, for the interesting question that returns all the time. We should avoid any confusion with other polymers. PS is not damaged by hot water. PS is also not damaged by multiple extrusions. Of course, you can damage if you want to damage, but in a regular, normal way, it is not damaged. And so it has this particular advantage that the processes that are applied here are not really damaging, and it's all about how well do you sort and how well. So basically, we did tests in labs, and ultimately, after 10 re-extrusions and recyclings, we do not see real differences. So it is, I think it's quite irrelevant as a question here. So that's my.
Excellent. Solenne and Chris, what is your take on this one?
Yes, indeed. And concerning the dissolution process, as I said, we remain low temperature, so we do not damage the polystyrene. I mean that we keep the entire molar chain, and this allows us to keep the mechanical properties into the polystyrene. That's very important in order to get a high quality end product, and so to be able to set a circular economy. So definitively, our process do not damage the polystyrene. As Herman said, if you want to do it, you will be able to achieve it. But with an under control process, you will not damage the polystyrene. You will keep the mechanical properties and be able to set a circular economy, and all of that with an efficient energy consumption.
All right, and you mentioned it, low temperature. That was also a question. What is actually the temperature used in dissolution? Can you give us some
room
insights?
temperature? The dissolution and the precipitation, both of them are processed at room temperature, and the same for the purification process. It is at room temperature. It does not need any warming.
Thank you. To you, Chris, for depolymerization, how often can it be recycled?
Yeah, thank you, Chrissi. So as long as there's feedstock, we can depolymerize it. Even if it has been degraded in application or reuse, we will recover the styrene from it and put it back into the supply chain, and it becomes a feedstock again for us in the future. So it's a fantastic question, and chemical recycling, since we are interested in the chemistry of it, we just recycle the molecules over and over again.
Very, very encouraging. The next one, also related to and over again to food contact. Yeah, that is what you're saying.
That's correct. That's correct.
No. Okay. Again, food contact question. How does the aim to have food contact quality affect the LCA results? And how does the waste collection affect the LCA results? Thomas, if I could put this question to you, please.
Yes, of course. Thank you, Chrissi. I think it's very important to come back to this aspect of food contact and how it affects the LCA once again. And as Herman van Roost pointed out in his presentation at the very beginning, food contact is a very ambitious goal for the recycling, and we have to take certain efforts, for example, the super cleaning step within the mechanical recycling, but also within the dissolution, we have to clean the solvent once again. And we all took this into account in our calculations, and of course, it affects the overall energy consumption. So we can say if we would not aim for food contact, we would have, of course, even higher CO2 savings, as pointed out in my report.
Norbert, would you like to also give your perspective on how the food contact quality is affected, or which effect it has on the LCA results?
As mentioned, we were aiming for the highest possible class, namely food contact, and therefore we took the factor of 1. That's what Thomas Neumeier explained in his presentation, and that requires some stringent preparation, and therefore we put all this effort to aim for the highest quality into our LCA. And that's what I mean with we are conservative people. A few minutes ago, we were not compromising on that. We said if we really want to stay ahead of the pack, so to say, with polystyrene, and we do, then we have to stay with the highest possible quality, and that's what we factored in the LCA. So it's in already, and therefore we can say that yeah, blessed by these natural constants of polystyrene, we can say it's a perfect material regardless of which recycling method you decide.
And I would add that there's one aspect on it that was touched on in the question regarding the feedstock preparation. Norbert, you also discussed that. For chemical recycling, you don't need as much enhancement of the feedstock prep, and you can still get back to food contact quality. So that will have an impact, hopefully positive, and that's something to discuss and optimize in the future. Is we used a constrained view for all technologies so we can compare them, and I think you will have a uniqueness and a specific LCA for each technology as well that can be optimized even further.
Absolutely, that's an excellent complementation and shows the robustness of the depolymerization process as outlined by Chris.
Again, food contact. What is the status of SCS application for food contact authorization, and when do you expect to get an EFSA opinion? I put this question over to you, Jens, please.
Yeah, thanks, Chrissi, for this question. And as always, the difficult or political questions land on my desk, but I try to answer in a way what we know. So regular process of EFSA, and it's important to mention it's EFSA and the subsequent EC approval, Commission approval following thereafter, is 6 months. Yeah. In case of queries and more intense dialogue with EFSA, it can be extended by another 6 months, so you can add, as a worst case scenario, 12 months. Yeah. What we know today is that we have started with a solid case together with a very reputable Fraunhofer Institute. I think we provided really a solid EFSA petition. Just to tell you, it will allow up to 100% of recycled content, which of course is just showing the dimension and the quality of the recycled polystyrene from the mechanical recycling. And the first questions from EFSA we received, these are all going well. It's an open process, but I would say, yeah, we are in good exchange, at least with EFSA. And I think the good news, coming also back to what Tobias mentioned in his part already, we can start already. We have already converters, we have PRs talking capacity. So for the converters, for instance, using ABA in the
Somehow the sound is gone for Jens. Can we bring that back, or is it just for me?
It is locally to Jens. Unfortunately, he's lost signal. He's dropped out. Jens, you can probably hear us. We lost you there for a moment.
I hear you.
There we go.
I hear you. I don't know what happened. When did you lose me?
You were just saying, referencing to Greiner and Migros.
Yeah, maybe just to add, this was I think my final here. What we learned from Tobias also, that we can start today ABA middle layer recycled PS with the recycled content of, for instance, 30%. That of course today is already considered to be drop in, and of course it's proven we are working on that already, as we learned from Tobias.
Excellent. Here's directly a related question to Matthew, I guess. When do you expect to bring the recycled polystyrene yogurt cup onto the Swiss market? How far are you down the road? And do you need authorization to do that?
Yeah, of course. Basically, when we have the correct, the necessary authorizations, I think technically we've shown it's possible. But we also then need the recycling loop in place, and it's a little bit more complicated. Maybe Tobias can add to this, because of what we can process and recycle where within Switzerland or within Europe. So there's a process still to go through. Tobias, maybe you want to add to this. I think you have a bit more knowledge here.
Yes, of course. So we are in close loop together with the Swiss authority, and the decision and also the question is how we get the material, where we can really recycle it. And there are some open questions where we are actually discussing together with the Swiss authority and the recyclers. And as Matthew said, we have to close the loop, but we are expecting progress in the coming month.
Excellent. And I understand from you the yogurt cup itself, the packaging is ready to go.
Yes, packaging is really ready to go. We tested along the supply chain, thanks to Migros, that we could testing really the whole supply chain. And from this point of view, everything is done. But at the end, a big question is the feedstock, also in Switzerland, and that is where we are working on.
Wonderful, thank you. And I think a question that really fits to that is a question to Werner. What does the European Commission do to expand and improve separate collection of all plastic packaging? Are any binding measures intended?
Collection is at this moment already in waste legislation, and in theory all plastic packaging needs to be separately collected. The pressure on member states to do that will only increase. What we are now doing in the revision of the Packaging and Packaging Waste Directive, it's not part of that, because that are separate rules. These are rather governed by the Waste Framework Directive. We will look again at the Waste Framework Directive in, let's say, 2 years.
Excellent, thank you. And may I just ask all the panelists to mute themselves if you're not speaking, and obviously then to unmute you when you're taking up an answer for the audio quality. Thank you. Here I have another one. How do you define the mass balance approach? And do you need to determine the recycled content when you use PS depolymerization? I put this over to Chris, please.
Yes, it's a fantastic question, as the existing infrastructure for styrene monomer production is quite large compared to the chemical recycling infrastructure today. So mass balance approach can be used. Agilyx has deployed a solution that's completely segregated and separated from the existing infrastructure and assets. So you can make pure styrene monomer that's 100% recycled content that could be used in the downstream supply chain, or you can use the mass balance approach, depending on which client or customer is preferring to use that. If you have an existing distillation system or purification system, by all means, it makes capital sense to reuse that. But through our collaboration and partnership with Technip Energies, we're able to provide a direct solution, a direct circular solution, all the way from waste polystyrene or post-use polystyrene to 99.9% plus food contact grade styrene monomer. Sorry, Chrissy.
Chrissy, you're muted.
Yes. Another question here. How much polystyrene recycling capacity will be operational in Europe by 2025? Over to Jens, I put this.
Thanks, Chrissy. A great question, and yeah, how to approach that one. I think best would be if we narrow it in a way that we say, okay, what do we know, what do we have? And of course, this question relates to what will we do more as an industry, as a value chain. Referring to Werner Bosman's, we have a clear direction. 50% of all plastics packaging being recycled, reused. 25 is giving the benchmark. You learned about our 800,000 tons at least of packaging markets. So you can easily do the math here. what it would mean. Yeah, the same would be, and we trust it will come. Werner explained that on mandatory recycled content, this surely will be in a significant scale also. Looking at this baseline for us and looking at our today's existence of capacities, it would mean at least adding another capacity in the scale of 200 to 250,000 tons, coming more by 25. Yeah, and this is despite what we expect, having a drop in the mechanical recycling contributing to that. Of course, Mount Everest, we know that. But if you look at the first PRs we saw and the invest of the industry and the value chain, I think what we learned in 2.5 years of SCS together with our value chain, we somewhat learned that we are moving mountains already. So the said Everest I was referring to, I think also we will move that one. Yeah, so it's a huge attempt, but we are confident by 2025. And as Werner said, also on the way, getting there in the continuous dialogues that we will perform up to what we have to do from both policy and value chain aspects.
Excellent. And I think here's another one over to Werner that fits into the text nicely. It says, industry needs certainty to invest in innovative technologies. And how does the Commission intend to bridge regulations in progress and the certainty to invest that industry needs?
That's an intriguing one. It's obviously a chicken and egg, but I think the headlines of policies are extremely clear. Sustainability, which is a concept that we know since decades, was a concept we knew. Today, it's at the top of policy making. So decreasing your environmental impacts will just remain there. And this is not just a question of political will, it's a question of survival. I mean, without the planet, what are we doing? So it is imperative. What we're doing to make that happen is policies on all sides. You are aware of our climate policies, climate neutrality. You are aware of circular economy policies about waste. So more on the detailed level, we will continuously increase collection and recycling targets and recycled content targets, because both need, unfortunately, to be linked, because, well, you all know the story. Pollution is not paid now, it's not integrated in the prices. Economists say the externalities are not internalized. But so pollution is still too free, so meaning fossil fuel is still relatively cheap. You might think differently in absolute sense, but not if you take environmental impacts into account, which means that there's still a difference between virgin and recycled. So targets will be needed and will be established aside voluntary steps from industry. So what is the regulatory certainty that you need? I mean, everybody within the regulatory business, be it on European level or member states, is going forward with this. How fast it is going to go, that's another question that we don't know. That is part of the political process. I hope it gives us some outline.
All right, great for that. I realize we are already a little bit over time, but we have a flood. I would like to address 4 more questions, if you can stay and bear with me, and give short answers to the ones. A question on design for recycling, in specific mono PS, the LCA, and I would like to quickly put that forward to Thomas, and maybe then Herman can answer on this one. Go ahead, please.
Yes. Yeah, design for recycling is a very important point, which has also been outlined by Werner Bosmans in his presentation, and for sure the LCA will benefit from design for recycling. As you saw from my slides, in all the processing chains and all the flows, we had always impurities to treat with. And if we come to design for recycling, we will minimize these impurities or reduce these impurities, and for sure this will have a positive effect on the CO2 emissions which we have in the recycling processes.
Yes, indeed, I can only confirm that, of course. Actually, we have now started up our new work group on circular design, and the mono-PS yogurt cup is one of the topics, and that we will, let's say, we will be able to tell more about it in the next session. But it's for sure, if you have no aluminum, no paper, no glues, no other plastics, and you replace all that by PS, it has a double effect. First of all, the processes become more higher performance, but you have also more feedstock. Instead of 70% in the PS content, polymer content in the bale, you will have maybe 80%. So it has a really great effect. And now that we have established 3 processes, the next step, and we feel that very, very well by the excitement of the value chain, is to work on the design for recycling. Before, obviously, it made no sense, but now it's a hot topic.
Excellent, and we will hear probably more about it in the next upcoming seminars. Is PS recycling economically viable? Again, quickly, Herman, Solenne, and Chris, looking at your technology. Herman, if you could take that first, please.
Oh, yes, it is. We made a blueprint, an industrial blueprint of a line with full-scale capacities, actually, but really reasonable, comparable to PET recycling, etc. And I can tell you that you can produce recycled food contact PS for in a very competitive way compared to virgin. That's definitely, and it's logic. LCA result in general goes together with cost. So basically, the answer is definitely yes. And on top, the product will be high in demand. So I would invite any investor interested in good business opportunities to contact us, and we will certainly help them forward in the right direction.
Excellent. Solenne.
Yes, indeed. I do confirm that the dissolution technology is highly profitable in order to recycle polystyrene. The transformation costs remain very low, and capital expenditure is very affordable. So definitively, this technology allows a quick return on investment. That's definitively true with the regular price of polystyrene, but as Herman mentioned, recycled PS is a high valuable product, so this makes it even more profitable. So the same, I invite you to contact us in order to get more information.
Yeah, that's what else more can I say besides yes, succinctly it is economical, and I appreciate Solenne and Herman saying contact us for interest in us putting forward a way to deploy these facilities and get more recycled content on the market today in an accelerated fashion.
Excellent, wonderful. And then there is one question that is maybe not a question, that was more a statement. I'm trying to pull that up here again amongst the many. I read it more as a statement, and it says, we observe a strong PS bashing. Where does such an opinion come from that would eliminate pollution or recycling issues by replacing polystyrene with other polymers? Also considering polystyrene as a foam, we see there is no plastics there with as many recycling possibilities as polystyrene. So I'm not sure, Werner, whether you would like, that was addressed to you, whether you would like to comment on this one. As I say, it's probably more a statement than a question.
I mean, we can't be responsible for the bashing of others. So what can I say there? I know that there are some critics, and let's just reply to that extremely generic. Critics are mostly, they have some truth in it and some exaggeration. It's like there are critics on all plastics as well. I mean, there are problems associated. I'm not too much aware of the specific problems associated with polystyrene. I am a bit more aware of the problems associated with expanded polystyrene, especially in the on-the-go market. And it's one of the reasons why the co-legislators, on their own initiative, so Parliament and Council, has added that to the directive, because once it is littered, it is extremely difficult. It crumbles, and it's extremely difficult to clean it up afterwards. And it's found quite a lot. So that part I do understand. Then the other part, and that is your own industry is working on it. The recycling wasn't really happening. But apparently this is taking off now, so congratulations for that, and I hope you manage to continue that. I would maybe like to add a question of my own on this thing, if I'm allowed. How are you going to take care that it's enough collected, sorted, and brought to the recycling plant? Because it's not only the recycling plant as such that you need to be able to recycle it. The main issue for some polymers might be making the logistics work, and obviously the costs related with that.
Excellent. Herman, would you like to comment on that? I see. Okay, let's go Herman first, Chris, and okay, go ahead.
Absolutely, you're absolutely right, Werner. And so we have quite some expectations in terms of regulation, but we don't. Instead of coming back all the time to that, what we decided to do was to create a market pool. And how do you create a market pool? By starting at the end, making a great product that will be in great demand, justifying investments, and then the investors, they will go looking for their bales. And I have never seen a sorter that would refuse to sort out a product with which they can make money. And so this is the system that we put in place. But of course, some help from authorities will certainly be appreciated. Definitely.
Yes, it's a fantastic question, Werner. Where's the feedstock? And Agilyx is based in, started in the west coast of the United States, and polystyrene was not accepted in the recycling and still is not today. And so it didn't, how do you go get it? And that was one of the fundamental questions that we had to answer as a company, and we've done so successfully. So much so that we actually formed a subsidiary, Agilyx, to address the feedstock logistics issue, especially for chemical recycling, because mechanical recycling has looked at plastics and its physical properties, not its chemical properties. And so we have established a logistics and supply chain company that looks at the chemical value of plastics, and are deploying systems and technologies to enable and increase the acceptance of plastics back into the supply chain. Whether it's mechanical recycling or chemical recycling, doesn't matter. We're aiming to increase those recycling rates 90% plus. That's our vision statement, 10 to 90. So it's a fantastic question, and it's something that we invite folks to discuss with us. It's very much a collaborative effort, and it's a great pursuit, and you need the demand, as Herman said, as well as the supply.
Excellent. The
collaborative. Maybe just to add on that, what Herman said, Chrissi, sorry to jump in. But surely, first of all, a great question. Secondly, and Herman knows he's leading the working group, waste mobilization, and now also going the full route up to incineration, pre-extraction of incineration is really key for SCS in order to mobilize the waste stream and to feed those capacities we are all shooting at. So it's part of the strategic exercise to say, so And you will learn about more soon to come, even up to design for recycling, improving sorting, collection, all that. We are very heavily working on that one.
Excellent. I would like to close with one last question, really short, coming from the dairy industry, saying, why should a dairy producer work on recycled polystyrene versus other solutions? I'd like to give that over to Jens as the last question.
The question is really a good one, and I think easy answer would be looking back at the past almost 2 hours. I think we got a lot of very valid information. We have a very now completed polymer recycled polystyrene doing all it takes to be really circular. We could refer to Matthew from Mikko and his testimonial. I think that tells it all. But also this tells there's no need to look for alternatives. Recycled polystyrene has all what it takes. In linear, it's material of choice in the dairy market for the brand owners. And this also is now clear, proven, and evidence that it will be the same for the recycled, circular, closed loop, even food contact route. So what else can be? And I think together, next to our healthy competition, we are holding with PET. In this segment, recycled polystyrene will continue to be predominant. And therefore, it is all there. And the food contact closed loop, what we learned today, Werner confirmed the strategy for plastics is an ambitious mission for us. But as we also heard from Werner, we are on a good way, and we will continue our path here. And even this with climate neutrality and food sustainability, what I think is now the really objective. You have to be circular, but at the same time, you have to be climate neutral and you have to be sustainable. This came clear.
Excellent. What a great statement to close this Q&A with. That ends the Q&A session for today. And before we depart, I would like to make a couple of brief announcements. First of all, if you would like to watch this webinar again or share it with a colleague, then we will make a replay available on our website, but also if you have signed up for our news, then you will receive the link automatically, as well as also for the further invitations to future events. Also, we will be relaunching our website to provide you with further resources, so that is also coming soon. And all of that leaves me to say a very big thank you to our attendees today, to all the wonderful people and organizations that work with us across the value chain. We heard collaboration is key. To our fabulous speakers, to our panelists here, to Werner Bosmans for joining us, and Vicky and Packaging Europe, and foremost also Kane and the technical team that made the technology here and audio work magic. Thank you so much. Take care and see you soon. Bye-bye.
Thank you. Take care.
Thank you.
Bye-bye.
Bye-bye.